So in this experiment we're going to look at the solubility of different compounds in a non-polar solvent. Okay, and the solvent we're using is hexane. So the first substance that I'm going to add to the hexane to check its solubility is some wax. Okay, so I'm going to put some pieces of wax in there, give it a little shake, and then we'll just leave that there for a few minutes. Okay. Next, I want to look at propanone. Okay, propanone with its permanent dipole-dipole interactions. I'll put some propanone into the hexane, and you can see straight away there that propanone is completely miscible in the hexane. Okay. Next, we want to look at ethanol with its hydrogen bonds between the molecules. So if we add the ethanol to the hexane, and give that a little shake, you'll notice there that ethanol is also completely soluble in hexane in the non-polar solvent. Next, I want to look at water. Okay, if I add some water to the micro test tube, and you'll see there that the water has formed a layer. Okay, there it is, insoluble in the hexane. Okay, you can see the two layers there of the two liquids. And finally, I'm going to add some sodium chloride, ionic solid, to the hexane. I'll give that a little shake. Okay, we'll have a look at them all in turn now and see what we can see. Okay, so if we start with the candle wax, it may be difficult to see, but the wax is actually starting to dissolve in the hexane. Okay, there's a lot of candle wax in there, so it probably won't all dissolve, all probably form a saturated solution of the wax in the hexane, but that candle wax is starting to dissolve in the hexane. If we look again at the propanone, it has completely dissolved in our hexane, as has the ethanol. Water, you can see the other two layers, water and hexane, are insoluble in each other. And finally, the sodium chloride, you can see there that the sodium chloride is insoluble in the hexane non-polar solvent. So in this experiment we want to look at the solubilities of various compounds in water. Okay, so I'm going to start off with looking at some wax. Wax, as you know, contains only London dispersion forces between the molecules. So if I add some wax to the water there and give it a little shake, we can see there that the wax is insoluble in water. Okay. If I look at another compound which contains only London dispersion forces between the molecules, hexane. Hexane's liquid at room temperature. We'll add some hexane to the water. And if we look at that, you can see quite clearly, I hope, that the hexane sits in a layer on top of the water. Okay, the hexane, again with London dispersion forces between the molecules, is insoluble in water. Next, I want to look at propanone. Okay, now, propanone contains permanent dipole-dipole interactions between the molecules. So if I add some propanone to water, and give that a little shake, we can see that the propanone is soluble in water. Okay, it's dissolving in the water there. Next, I want to look at ethanol. Okay, now ethanol contains hydrogen bonding between the molecules. I'll add some ethanol to water, give it a little shake, and you can see there that ethanol, with its hydrogen bonds between the molecules, is soluble in water. Now finally, I want to look at some sodium chloride. Okay, sodium chloride is an ionic compound, so I'll add some sodium chloride to the water. Give that a shake. And we have to leave it a few seconds just but you will find that the sodium chloride is completely soluble in water. Okay, it's an ionic compound and it's soluble in water. Okay, so if I just take these away to try and show the camera close up their solubility, you can see there hopefully that the wax is just sitting on top of the water. It has not dissolved. Next was the hexane. You can see the hexane is sitting as a layer on top of the water. It has not dissolved. The propanone has dissolved. The ethanol has dissolved in water. And finally, the sodium chloride has also fully dissolved in the water.